Hi, welcome to our computer vision final project where we deblur animated faces using deep convolutional neural networks and compare the different models. Our project motivation was to explore how we could transform low quality and blurred images to higher quality images. Many of us have either downloaded or captured images that have resulted into being blurrier than we have hoped. In this project, we decided to explore the solutions for these issues by re-implementing and redesigning different deblurring models inspired by the paper Image Super Resolution using Deep Convolutional Networks.
The dataset that we use is a dataset of 92,256 by 256 images of anime character faces from Cargo. But we only use 1,000 of images for the sake of training time. These images were originally color, but since we learned that the model used in the paper did not work well with color images, we decided to apply a grayscale filter to them. After that, we blur every image 3 times using 3 different methods, using a box filter, Gaussian filter, and a custom horizontal motion blur filter.
For our model, we used a deep convolutional neural network model called SRCNN. This original model consists of 3 layers with kernel size 9, 1, and 5. The diagram on the right shows that when the model is given a lower resolution image, the first convolutional layer will use patch extraction to extract a set of feature maps. Then the second layer non-linearly maps those feature maps into higher resolution patches, and the last layer does the reconstruction. Since the paper proposed alternative versions of the SRCNN model with different depths and filter sizes to experiment on, we decided to use 3 different SRCNN models and compare their performances.
For training, we decided to experiment with 2 different learning rates using 20 epochs. The paper that we read claimed that a small learning rate in the last layer is important for the network to converge, so we tried to prove that. After training, we compared the loss between different learning rates, kernel filter size, and number of layers to conclude how each affected our model performances. Here's an example of the plots we generated. As we compare the 3 models, you can see that model 1 and 2 result in a similar loss, and model 3's result was not very great. And this is an example of how our outputs looks like. For the box filter deblurring, it achieved the most satisfactory outputs, as most of the models result in significantly deblurred image close to the original grayscale image. For the 6 images, the top 3 are the original one, the grayscale and the blur image, and the bottom 3 are the results of each model. To view our full results and plots, please visit our website.
If we continue to work on this project, we hope to further extend it by using more complicated structures and explore more filters and training methods to achieve better results. We also hope to train on a full dataset to reveal the performance on bigger datasets and possibly optimize a model to work well on colored images. Thanks for learning about our project.